I want to go over what I think is the worst case inverse Laplace transform to take care of. When you have something like this, the first thing you always need to do is take care of the denominator first. And when I have something like this, it means I'm going to have to complete the square. So let's go ahead and do that. This is my first step to completing the square, and then finally I get this. Where students go wrong is at this point you focus on the fact I have this s plus 1, but then you go ahead and split up the fraction like this. And we're fine with the second term, but the first term is where we'd get into trouble if we tried to do this first. It's because when I have this s in the numerator and an s in the denominator, I have to have the same shift in s. In the left-hand side, I have 3s in the numerator, and I have s plus 1 in the denominator. I have to have both s's be in terms of s plus 1. So don't split those up into two fractions at this point. So what I did is I made the s into an s plus 1, but just like when I complete the square, I realize that what I've done really is added a plus 3. So to keep the expression equivalent, I need to then subtract the 3. Now I can split this up into two separate fractions. The left-hand term I recognize as cosine, the right-hand term I recognize as sine. The left-hand side now is actually easier to take care of. The 3 I can just pull out, and I'm just going to right now take note that I did have a shift in s, so that means I'm going to have to deal with an e to the t in there, but I'm going to hold off on that for just now. For the sine, we need to get that omega in the numerator, so to do that I have to multiply by the reciprocal of 3. Again, here's a reminder from the Laplace table that if I have a shift of s minus a in the s domain, that goes to an e to the plus at in the time domain. So since I have an s plus 1 in my s domain, that's going to translate to an e to the negative t in the time domain. And that's my final answer.